Okay, this is going to be an intro video to finding the antiderivatives of trig functions. So let's revisit original trig functions, their derivative. So if we have sine of x, remember sine's derivative? Sine's derivative is cosine x. So remember what you have to do when you're finding the derivative. So if you have this notation, all you do is think back. Well, what function's derivative is cosine x? So kind of work backwards. Oh, sine x. So this answer right here, is sine x. So the antiderivative, wow, that's not working very well. The antiderivative of cosine x is sine x. Now for some of these, they get a little bit tricky because of the negative sign, so you will have to be careful about that. So the derivative of cosine x is negative sine x. So if you have that says the integral of negative sine x dx, well then you're good to go. You can just say, well, that answer, capital F of x, is equal to cosine x plus capital C. However, sometimes they'll just say, hey, what's the integral of positive sine x dx? Well, we don't have any original function whose derivative is positive sine x. But what we do have is a function whose derivative is negative sine x. So you find the derivative or the integral of what that would be, which is cosine x, but then you have to remember to multiply it by -1. So you'll just have to be pretty careful. We'll do a few examples, so hopefully I didn't just confuse the heck out of you. All right. So now we have tangent. Just do this. So the derivative of tangent is secant squared x. So if you have the integral of secant squared x dx, the answer would be capital F of x is equal to tangent x plus capital C. All right. Again, when there's negative signs involved, whoops. Get rid of those. Okay. So secant x, the derivative of secant x is secant tangent. So if you have the integral of secant x tangent x dx, you just work backwards. Oh, well, the functions whose integral or whose derivative is secant tangent is secant x plus capital C. All right, so I think you might be getting the idea here. So for cosecant, its derivative is negative cosecant cotangent. So in order for this answer, if you had the integral of negative cosecant x cotangent x dx, that dx is a must, that answer will be cosecant x plus C. However, if you just have the integral of positive cosecant cotangent dx, well, since this is not negative, and that's the inverse of this, then the answer would be the inverse. So negative cosecant x plus C. All right, and then finally, cotangent. Cotangent's derivative is negative cosecant squared. The antiderivative of negative cosecant squared is back to cotangent. All right, so Hopefully you'll watch the intro video before doing the samples. The next video will be one example of each type of those trig